Everyone is under pressure to produce faster and to do more with less, which often means that programmers are behind the scenes reprogramming millions of lines of code. And no biggie, but if they get it wrong, the whole house of cards might just collapse. So how can you use generative AI to modernize your applications and make sure you don't break anything in the process? Let's see today on AI in Action. In this series, we're going to explore what generative AI can and can't do, how it actually gets built, responsible ways to put it into practice, and the real business problems and solutions we'll encounter along the way. So, welcome to AI in Action, brought to you by IBM. I'm Albert Lawrence. Now today we're going to talk about how generative AI is transforming application development and making sure that what you spent years building doesn't break when you try to upgrade it. Today, I'm joined by Miha Kral and David Levy. Now, Miha is the senior partner of cloud build and modernization at IBM and self-defined software engineering nerd. Welcome, Miha.
Hey, Albert. How are you today?
I'm so good. I'm excited to get into this. And our other guest is David Levy, an advisory technical engineer for IBM Client Engineering. He builds things, y'all. So why did I choose you two for today's episode? Well, because you both geek out about the build. And today I want to explore how to modernize your applications faster, at lower cost, and with less risk using generative AI. Plus, the different ways developers can use it to make life easier. So we're going to get into all that. Let's start off with our first question, though. I want to direct this one to you, Miha. How does generative AI change the application development cycle? And for the folks who haven't dipped their toe in yet, what are they missing?
Well, I typically compare how job of a software developer is changing the same way how the job in car manufacturing changed. If you remember, in 50s, car plants were typical conveyor belts and blue-collar workers were welding on it and painting and putting glass in, and at the end you had a human to do the inspection of the car. If you're looking at any modern car plant today, they're all robots, right? Robots are welding, robots are painting, robots are putting glass in there, and robots are doing the final inspection before car is sold off. Now, the question is, where are humans now? Well, humans are making robots that make cars. And that's very similar to what's happening to a software development profession. Instead of directly making code, we are going to make instructions, prompts, to make code in the future. The second part that we actually see is that you can use generative AI in the software development lifecycle either for good things or for silly things. Let me explain. Generative AI can generate new code, but then if we let generative AI to do that, somebody else probably needs to write the documentation, write the tests, do all of the things. And I saw in early stages that in a worst case scenario, developers just became butlers for generative AI. They were literally copy-paste in one direction. Generative AI takes that as a prompt, spits out some code. You copy-paste code back. You try to compile. Doesn't work. That's not how we do it these days at all. In general, all of the tasks that developers have to do in a traditional life cycle because of engineering excellence, coding standards, and discipline, typically we prefer to offload those, like let's call them the toil type of the tasks. Definitely, for example, a developer these days is just going to write the whole class or function or routine or whatever the language is, typically without massive amount of comments in there, and then ask generative AI to comment out the code, to actually explain in human language what the flow of the code is. Very, very frequently, we actually see that the lazy developer is going to use a single letter variable names, not just iterators, but in a general, inside your class, you're going to just say, I don't know, C for a customer. And then at the end, you say to generative AI, please rename all of that stuff. And it is just going to go and put intelligent names to the variables, to the fields, and so on. These are just a couple of examples where generative AI can be used as a very useful power tool, but is not replacing the creativity that we still expect from human developers to shine through.
The creativity thing is huge. Like, you're not going to get the generative AI to be creative about a solution, but the documentation, that's it for me. Because documentation is tedious. And if you want to make something really well documented and you're sharing your code amongst a team, or you're making an asset for other people to use, and you have a complex pipeline, and when you look at the code, you're seeing a function call with a bunch of parameters. With modern IDEs, Vim even, like you could just hover over it and get a detailed explanation of what that function does by writing good documentation. And that's what I use almost exclusively. Generative AI is unbelievable for that. It's such a boon for developers.
So then with all of this and with that tool truly being so useful, but now I'm curious about how do you actually use generative AI to transform an application?
So there are languages that are performant but old, like COBOL, right? And to modernize an application that uses COBOL in the mainframe, you could have a plugin in your VS Code where you're able to have two panes, one with the COBOL and one with, let's say they're converting it to Java. And you're able to do the whole suite of like transformation, testing, and LPAR, and all of this stuff. And it's just, like Mia was saying, the human is still in the loop. You're not asking it to do it all on its own. You're doing it and you're testing it and you're making sure it's working and you're understanding what the COBOL programming language is doing. And then you're able to convert it to something in Java. And you just have like a first step in the transformation. And that is a huge leap forward from just trying to write it on your own.
Well, then, is this a separate set of tooling then that's required in order to do this? Or does it integrate into somebody's current existing environment?
You can integrate it into VS Code. Most programmers are running some kind of IDE, and VS Code is probably the most popular, and they're able to integrate this kind of tooling into VS Code.
So the way how tool chains work for developers, it's extremely hard to say what's a separate tool and what's integrated tool. So for all developers will use, let's say they open Visual Studio Code as their coding environment. And then they're going to load sometimes up to 20 plugins, and every plugin is a separate tool, sort of. You want a plugin that color codes your code. You want a plugin that is actually linting your code, so properly aligning it. You can have a plugin that is looking into your syntactical errors, or you can have a plugin for AI.
Okay, I'm getting it now. It's all coming together. But with all these different codes, with the building, I'm kind of curious about some potential pitfalls.
I actually want to give you an interesting example that is not necessarily code conversion, and it can start, let's say, with Java or with any of the current languages or JavaScript. Typically, developers are going to create a relatively simple flow of code, the way how brains work and the way how logical path needs to be captured. And then typically, after it works, then you start teasing AI and you're asking, can you make that more performant? Can you optimize? Can you make it even more optimized? And if you do that too much, you actually get to a very interesting side results. For example, I saw a couple of examples where developer writes a fully functional class, the object in object orientation programming. And when you start to push a large language model to optimize, one of the changes that LLM does, it turns the code into functional programming code. So it drops objects because functional programming is generally more optimized for speed than the object-oriented coding is. And when you keep pushing it further, suddenly it starts to do everything in async calls and it's just throwing awaits everywhere. So at the end, what I'm trying to explain is that you get a code that flies, but regular human brain can't even debug that properly because you now need to start to trace. If you have a parallelized path, that is extremely hard for a regular developer to do the async programming debugging, and especially in a functional programming paradigm. Suddenly, all of those things come together, and yes, it works, but it's no longer for human consumption. It looks like complete cryptic hieroglyphs that maybe you need to put it to another LLM and say, rewrite for humans to understand.
That's really interesting. Like I guess if you prompted to say, keep it class, keep it object oriented, and you could try to make it more performant that way. But I have seen that in action, like exactly what you're saying, where it just starts converting an object oriented program that I'm writing into the async await, not async await, but like await chains, like this callback insanity that I had to be like, all right, you know what? Let me just start over, write it myself, and then ask it to document it for me.
The other example would be of it's not that it goes wrong, it just goes weird for regular humans to understand. To try to give you the analogy here would be like when you want to optimize some nice writing, some nice narrative in English, and you would get a complete legalese out that actually means the same, but you just can't choose through that text. A good example would be where most of the LLMs, when you ask them to optimize regular if-then chain statements, it turns into ternary operators, which most of the languages support ternary operators, but they are really hard to comprehend for a regular human. The syntax is not trivial. And once you start adding the whole lambda anonymous functions in it. So very much what I'm trying to say here is that LLM can almost start to write assembler level weird constructs, which, yes, they will work, but they will make code unmaintainable, incomprehensible, and it is not a good code to then actually commit. Code needs to be understandable for generations. It's not just something that one nerd puts together and then, everybody is going to admire that masterpiece monument on GitHub or GitLab or wherever it's published. The code is extremely human collaborative thing. And if you use somebody that is smarter, not really, but makes code that looks smarter, that's actually a very, very bad anti-pattern.
Well, then how do you keep the human in the loop then when you are coding with Gen AI? Is that possible?
It is with a very long prompts, right?
But even like avoiding anti-patterns, avoiding relying on generative AI to write your code for you. And I have, nephews who are interested in computer science or programming. They're young, and with ChatGPT, they're like, oh, I'm just going to have this write this Lua script for me in Roblox or whatever it is. And they're not understanding the principles of programming. Like there's they didn't read The Art of Computer Programming. They don't understand the principles of what they're doing. And so they're relying on, like Mia was saying, this really hard to understand, like complex solutions to problems that work well, but they're not understandable. And even learning from Gen AI in that way is pretty terrible. So you have to really go into it, understanding what you're trying to do, and then using Gen AI to augment your workflow, augment the stuff that you're writing, document it in my case, and stuff like that. That's where it really shines. That's, I think, its most profound benefit.
It seems like the power of really learning and understanding is key here. It's about more than just being able to make a thing or know a thing or quote a thing. It's about that understanding.
Understandability is definitely the key, yes.
Well, look, here's something else that I'm wondering about in terms of key. When I think about governance, when I think about monitoring, do those things have any sort of a place here in this conversation?
Yes, and we didn't solve them all yet. And lots of a discussion how to do that. One of the projects that we are doing recently is repeatability. So we always expect in computer science industry that when we do something that it can be very much repeated again and again and again. And that's why very much infrastructure as code exists. And, we commit all of those things into a source control. The way how we actually code with generative AI, because it's generative, it makes things and it makes them slightly different each and every time. So when you give it a spec, let's say I want a class that is going to do blah, and it will generate code that might be perfectly fine and it works. But every developer that I know is going to ask for another generation and another one, and then is going to stare at 4 or 5 of those different variations that came out, and all of them are slightly different or sometimes significantly different. And then human just kind of arbitrarily goes, oh, I like this one most, which is all great, right? And the code goes into a commit and everything is fine. Here is the core problem when it comes to governance. How do you repeat that process? Because the next person, even if you feed it exactly the same prompt, is going to get another 5 different variations, and none of them is the one that is currently in our source control. So if somebody wants to walk the same steps again, it can't. We need to find a new way of governance to say, well, when you asked it blah and it generated material based on your prompt, we need to start tracking these things, or we need to start tracking the temperature number or something that makes the process repeatable. Otherwise, at the moment, it just goes one direction. At the end, you get the code, but you cannot repeat the process the same way again.
That's really interesting. And it's also like a little bit philosophical, right? Like you're saying that it can't repeat exactly the same solution, but it gives you a solution. So you're asking Gen AI to give you a solution. It succeeds in that, but it's not exactly the same. What's the benefit of having identical responses to the process. Like understanding that there are many solutions in all computer science to figure out a solution for a problem. What's the benefit of having the same solution over and over again, though?
Let's say that you want to add one feature into the code. Are you going to, as a typical modern processes go, you want to prevent the drift. So you are removing the current branch of the things and you want to start with a new additional requirement, but you start from the beginning and you want to regenerate everything. You just can't, right? Because you are not going to get the same thing out.
When we're thinking about that, even with, the difficulties with governance there, how can somebody get started with using Gen AI tools in the coding or in the modernization process then?
If we're talking technical, we're talking computer science, data science, stuff like this, having a background, at least in a foundational understanding of what you're doing before you start using these tools, I think is necessary. Otherwise, it's not a good way to learn if you're given the answer to something that you don't understand how they got to. Like the process actually is really interesting. How did you get to this? If you're just taking a block of code that's generated by, an AI, and then you're plugging in and it works, but you don't understand why, that is an issue in learning. And so having a fundamental understanding of programming is, in this use case, is necessary. But to get started using it, easy peasy. It's you can find tools anywhere, and good tools almost everywhere. You just have to learn how to use it, and it's simple. Just go into it, start doing it.
It's almost a maturity scale. So I would say that once you install the generative AI tool of choice that is using the backend model of choice, and different models and different vendors are doing different things, we can talk about it later. But the usual stepwise, the first thing that typically developers should start doing is doing a very simple /explain, which is ask generative AI, what is this code? So through that, the generative AI typically is going to write in English language how it interprets whatever code you are pointing to. The next step is typically /fix, which is find the error and fix that error. Third one would be /test, which kind of generate tests for me and make sure that all of the boundary conditions are properly validated and tested. And then the last one is, of course, generate new code. So if you're going through that, it's kind of almost the easiest one is just to ask almost like some very senior developer, can you tell me what this does? That is very much the easy first step for developers to start.
So how do you even decide between the generative AI options that are out there?
You actually try multiple models, and that's one of that level of complexity and lack of governance that we are trying to address these days. If you're looking, for example, how developers, and we interviewed a whole bunch of that, there is a joint project between IBM and Red Hat right now where we are really intently looking into how new software is created with these tools. They're typically going to create a prompt and throw to 2 or 3 different LLMs and see results coming back. Based on that, change the prompt and maybe make a different selection of LLMs and then change the prompt again. And then maybe they're going to say to one LLM, can you test the outputs from the other LLM, and then create the chain of those agents. And then at the end, very much using them like a power tools and agentic approach to generative AI, which means that they become agents, that they start to talk to each other. One generates code, the next one does the semantic parsing, the third one does the static code analysis, and the last one, for example, does the full end-to-end black box testing. These are all potentially different LLM engines, different LLM models, each one specialized and being best in one of those specific tasks. We have models that are not great at all in generating new code, but they're absolutely amazing in verifying and testing existing code. How to choose which one at the moment, it is still a little bit of a dark art, and that separates a good advanced AI software developers from beginners.
Okay, well, look, we've been kind of talking about things in ideal scenario, right? So we've been kind of imagining that your organization has all the resources in the world and can test all these different tools on out and find the perfect one that's for you. But what if your organization just doesn't have the tools that you need or that you want to use? Are you just out of luck?
It's a very typical approach. Until we understand it, we are not going to allow it. But there are two separate problems here that we need to address. Why are companies so reserved and risk averse when it comes to using LLMs for, let's say, some, important code, let's say mission critical system code and so on? The first problem is, of course, as you mentioned, giving that code to LLM. Until there is a very thorough legal review, if you push code to some SaaS service or API endpoints that is outside of your organization, what happens with that data that you gave out from there? So the first problem is, how are they going to treat the data? But the second problem is, what was the model trained on? And that's why those two things are super important. Where it runs, it could run inside the walls of a data center or in a trusted environment that has a very strict and very well-defined legal limitations. But the other part, which is the model open sourced and published and fully vetted by broader audience and scientific community, or is it commercial, closed source, dark, arcane art, and you should just trust it, right?
So in closing for today, here's what I'm thinking. I've got a few takeaways here. Generative AI won't replace you as a coder, but it will seriously help you code. Code should be built to last for generations, not just for a moment in time. And having a fundamental understanding of code is still critical to code using generative AI. So basically just keep playing with all of your approved options, and emphasis on the approval, all right? So Miha, David, thank you so much for both of you for being here. This has been a fantastic conversation. That's it for this episode, but everybody, please keep on listening. Don't worry, there are a ton more good bites, good nuggets where these came from, and we'll see you again here soon. All right, friends.